All right, I don't think I've done any of these questions. I found them all somewhere, and I did them maybe back in the day, but I don't remember the techniques for any of them. So this will be exciting. First one, I'm seeing arctan vibes because I have a 1 plus something squared in my denominator, some variable situation. I'm not super stoked on it though because I don't have a cosine running about. But I don't know. Is this gonna work out? I'm not happy at all. I'm so unhappy. It's wild. I'm trying to think. I mean, just the two terms in the denominator are soul crushing. And even if I rewrite the sine squared as 1 minus cosine squared, I'm just like wasting time because I'm still going to have two terms. It's just going to be uglier. So I don't know. Let's F it. Let's just see what happens. So I'm going to say u is equal to sine squared x. Because if that were true, I could rewrite this thing as arctan. The problem and why I'm nervous is that my du then is going to be 2 sine x cosine x dx, right? Because technically, oh shit, I don't need that. Sorry, brains. I only need it to be sine x because sine x is what I need to get that arctan. I could have made it the whole denominator. Would that work? Now my brain is going. It's good. Cosine x dx. I don't have a cosine x though, so I'm going to add it into the problem. I can do that as long as I undo it as well. So let's go ahead. Let's just rewrite this stupid thing. Okay, I'm going to change my bounds. Sine of 0 is 0. Sine of pi over 4 is root 2 over 2. So we'll go ahead and throw those in. New bounds have been dealt with. Technically, I think this is now a 1 over... Maybe I shouldn't write the bounds yet. We'll write the bounds later. I'm just going to rewrite my original problem. Look at me. I can't even decide what I'm doing. So we have 1 over 1 plus sine of x squared. I'm going to rewrite it so it's obvious that that's what I'm going for. I know I need a cosine of x times that dx in the numerator, which means I need to add in a little undoing function here. I've got to also divide by that cosine of x. Okay, so that doesn't seem super helpful. I can change that. I can change the bottom. But then I'm still screwed. I still have the stupid cosine of x, and I can't, is there any, it's still in the denominator. Even if I use a trig sub, whatever. This is bad. This is bad. F it. So u sub is not going to help me. I gotta cut my losses here. It's fine. I'm going to leave this in the video. And hopefully, if I ever get to the answer, I'll leave it in the video. If I don't, then I'll delete this video and pretend it never happened. Okay. U sub to arctan was not a good choice. Maybe trig sub to tan would be a good choice. So let's try that. Sine of x is equal to, this would be great if it was tangent, right? If it was tangent of theta, life would be good because then my 1 plus sine squared of x would be equal to 1 plus tangent squared of theta. And we know that that baby is just secant squared theta. Cute. Love her. Love this for us. I don't love it, but it's okay because now I don't have to worry about finding other crap. I just need to take the derivative of this thing. It's basically, oh God. Can I do it? So x is equal to sine inverse. I so much regret. I'm just going to take the derivatives as they are. I'm going to do implicit. I'm not going to create a horrible chain rule. So derivative of sine is cosine of x. I need my dx. Derivative of tan is secant squared theta d theta. So, but now I have cosine with the nuts. This is not a helpful thing to have. This is not good. Can I figure out a way to go backwards? I'm just going to sub in really quick and see where I'm at. I'm going to ignore the bounds because the bound is just horrible enough, right? So right now I have secant theta squared theta. I know I don't, y'all, it hurts my soul to write down x and a theta in the same thing here. And we said this whole thing was just secant squared theta. Those would cancel. So the real question is there some way that I could write secant of x in terms of theta so that I could actually do this darned problem? It seems like I should be able to. Seems like I should be able to. So let's come over here and let's just say we know sine of x is equal to tangent of theta. So it's going to be really, really hideous. Sine is opposite over hypotenuse. 1 minus tan theta. This is horrible. This is really bad. Nothing good is coming of this. I'm going to continue down this route anyways. And secant of x is equal to hypotenuse over adjacent. Yeah, all I've done is like make this horrible in a different way. Because now I'm here, which is just a different version of the exact same thing. What have I done? How was I supposed to do this problem? What clever ass thing was supposed to come to my rescue? Trying to think what could have happened here. If I divided everything by cosine squared, change things to secants and tangents, but I don't think that would help me. I'd have a secant squared x all over secant squared x plus tangent squared x. That's not really that useful. Oh wait, maybe that is useful. Because I have a secant squared, I have a dx here, a du. If only I could rewrite all this stuff as tangents, and I can rewrite secant squared as tangent squared. I can, but that's just going to be able to, let's just go with it for a second. Means u is equal to tangent of x. We know secant is equal to 1 plus tangent. So now we have 1 over 1 plus 2u squared du. All that crap at the top is du. This would be a 1 plus tan squared x, which would mean I have 2u squareds. Now what do I do with this thing? Ooh, and I can change out my bounds right now. Let's just change out my bounds. Let's be good. All right, changing out my bounds. Tangent of pi over 4 is 1. Tangent of 0 is 0. Ooh, she's looking cute. She's looking cute. She's looking cute. She's looking cute. I don't like where the u is. I like that, like, I feel like I've gotten it somewhere good, and now my brain is broken. Let's add in clever. I don't even need. Oh, that's just arctan. Oh, the whole thing I was trying to get back to, some arctan. Okay, this is, I don't like the 2, so I'm going to pull out the 1/2. I can't, my brain, it's fried from trying 3 different things and finally getting somewhere with this. 1 over, if I factor out a 1/2 from this, there's going to be a 1/2 left over. It's really a 2 from the denominator, plus u squared du. So now it's still not great, but at least it looks a little bit more like arctan. This is a 1/2. We're going to have the square root of 1/2. Oh God, the square root of 1/2, 1 over that, right? So we end up with just root 2. So root 2 arctan of u over root 2. Wait. The root 2 ends up in the numerator. Hold on. Root 2 u plus c. And our whole u, oh my God, I had all this other nonsense, is just tangent. Wait, that can't work. Oh, it can because there's a root 2 in there, which means I can't undo it. We're good. Okay, wait. Root 2 over 2 arctan of root 2 times tan of x plus c. Oh crap, that was a definite integral. I didn't even need to go backwards. Hold while I figure out my life. How easily distracted I am. All right, so we have 1 and 0. So we're going to have root 2 over 2 arctan of root 2 minus root 2 over 2 arctan of 0, which we know is 0. So we just have that piece. And tangent is never just root 2 on the unit circle. It's either 1 or it's like, 3 or it's 1/3. So we're good. We can just box this up and be done. I hope to God that's right. It's 11 minutes and it took me like 6 of them to mess around and get to the right thing. But I do think it is valuable to see all those false starts and sort of realize it's not always like we usually make it look really easy. And most of the time it's not really easy.